Hello, I'm going to do a quick video, hopefully, on how to use Posit.cloud in order to run an ANOVA for your homework. So first thing you need to do is go to Posit.cloud here. This gives you access to a free online R environment without having to download files locally to your computer. So you're going to click on Get Started here, and you want to choose the free version right here. So you go down, click on Learn More rather, and you sign up. And you want to sign up with Google. And from here, you want to choose your university address here and sign in to Posit Cloud. So this gives you access to an environment where you can create an RStudio without doing anything. So you want to click on New Space here and call it ANOVA Homework. You hit Create. And then I want to content do because of course they have changed things. Data. Of course, they have changed everything, so I had to learn how to get this again. Oh, it's right there. It's hidden by this. So you want to click on New Project and New RStudio Project right here. So this will get into here. So it's basically loading everything up here. So one of the things you want to do is name the project. So I want to do this as ANOVA, so that I can come back later and see the fact that I'm running an ANOVA. So it's going to load into this right here. And this is the general RStudio environment. The first thing I want to do is I want to hit File, New File, and we're going to make something called an R notebook file because I want to create a PDF at the end, and this helps us. You're gonna come up with this bit right here that asks if I want to install required packages. We clicked yes, and that's going to sit and download a bunch of packages. Just let it do its work. And so it's just gonna do this. So while this is working, I need to upload the file that I'm going to need because this is on the cloud and not on our local computer. So I'm going to go down to the bottom right here and I want to click upload. And it's going to come up with this upload files. It says target directory. We leave this alone. Go to files to upload and I click browse. And then I have this in the downloads under HIM 230 week 7 assignment ANOVA sample data. You would do whichever one you're doing. And I click OK, and that uploads our file. I can see it right down here. So in here, I want to go ahead and want to delete all this information here. This actually has how you can put things in, and that's up to you to use. But up here, I want to title this. I could title it week or HIM 230 week 7 assignment ANOVA. So whatever I want to put in for the title for the document I'm creating, it's going to be right there. I want to go right below it and do author. And then I want to put my name. And I want to make sure I close the quote so it doesn't do weird things. So after this, because I want to make a PDF, I want to click on this little down button and it says knit to PDF. I want to click yes. And it's going to ask me to save. This is good practice anyway, because this creates a save file. I'm just going to call it AOV. Whenever you do this, make sure that you don't, and this creates the ANOVA file, which I don't really need open right now. Make sure you don't put a space in your file name because that can cause errors. So from here, we can start doing our work. When you're making this really quick, this top part up here is called YAML. I wouldn't mess with this unless you know what you're doing. It can get kind of complicated other than putting like your author. I don't need the HTML here, so I'm going to go ahead and delete that as well. And you can do all kinds of things in that, but we're not going to worry about that. Below that, this is called an R markdown. So a markdown file, I can do formatting. So like I could use the hashtag or the pound symbol in order to create headers. So this is the top level. So we're going to do data cleaning. I could spell here and load, and then I could just type and just would be typing like normal. And so we're loading the data. And now from here, I want to click on this little button up here, insert a chunk, and I could do R or these different types. We're mostly working with R, so I'll do that, and it opens up this part right here. So here's the file I want to load, and I'll show you how to do it easy. Instead of having to deal with the code, you can do this. I click on import data set, and it's an Excel file. You can do text, which is a CSV. You can do Excel, SPSS, SAS, and Stata. All those can be done right from here. But I click on from Excel. It's going to ask me for more packages because it's nice. And I say yes, installs more packages. And it's done in a second. And it comes up with this. So I click on browse, I click on this, and I hit open. So it opens this part right here. And then from here, I'm allowed to change how I want these things to be done. So this is what I'm measuring. This is the protocol, which is a character, that's fine. Surgical style, which is character, that's fine. Age is double, that's fine. Now, patient ID is technically numerical, but I don't want it to be because I don't want to deal with that later. So I can go in and change that to character. And then it will treat that as a character instead of a number. So if I want to do something with the patient ID later, it will work. Other thing I don't want to have is I don't want, because this right now, this is loading the name as this HIM 230 week 7 assignment ANOVA sample data. I don't want that. So I'm just going to use DF. So I just go down to this import options and type DF and hit tab, and it will rename things. So I could click import right now and work, but in order to make a PDF, you have to put it into the code. So what I'm going to do as in the code preview is I'm going to highlight this library and this DF here, read Excel, and I'm going to copy it. Then I'm going to hit cancel, and then I'm going to go down here and I'm going to paste it. And that pastes it into the data. And then I can hit this little play button and I can make sure it works, which it does. So I hit view DF, see that all my data is loaded. That's how you do this. So our data is loaded. So then I can go down here and then I can click down here, the next thing. So this way, if you're doing this as an assignment, you can just say, hey, this is what I'm doing. Check for missing values and outliers. And then I can either go back up here and click on this little down button and R, or you hit in Windows Control-Alt-I. I'm pretty sure it's for Mac as well, and it would open them the same thing up. So really quick here, we can do different options. So I can click on this button and I can name things so that it's easier for me to remember what I'm doing. So I can do loading data, and it would pop up here. Or you could also just come down here and do space, outliers, and missing values. So the quickest way to find missing values is do a summary of DF. And that will tell us, so this is character, it doesn't care, miss age, you can see min, anything here. But if you have something that's missing in the numerical, it would come up as NA. If you had something in here, it would come up as NA or missing. We don't have it, we're fine. The quickest way for me to always check outliers is to use a box plot. So I type box plot, open parentheses, and I do DF, a $sign, and then I go down, and then this list comes up. And I could choose any of these things, but since you can only do a box plot for numerical data, I choose post-operative pain score. I hit tab, and then I hit Control Enter, or I could just run everything again. Run, and it comes up with a box plot. So on this, the easiest way to check for outliers is to see if there's anything outside, like little dots above or below the whiskers here. So this is a box plot where you have 75% of your data in the middle, and you have these which are 95 to 97.5, depending on the method, where you can see whether or not you have outliers. And the outliers will be little circles that'll be up on the top or on the bottom. I don't have that, so we don't really have any outliers. Another thing you could do to see if there has to be transformations, and this is also one of the assumptions, but we'll cover it in a second, so we'll do that in a second. Oh, we have to choose to make sure that it meets assumptions of normality. So I'm going to do this to them as assumptions of ANOVA. Assumptions. So one of them is normality. And this is if we would have had to do transformations, it would come up here. That is the Shapiro-Wilks test for normality. So it's Shapiro.test, and I do the DF $sign and choose the post-operative pain score. And then I can run that. And what I'm looking for here is this produces a W value and a P value. If this P value is above 0.05, I have normal data and I don't have to do transformations. If it's below, it'd be non-normal and I'd have to do transformations, but I'm good. So that and does transformations doesn't have to be done, and I had to check for homogeneity of variance. That is done based off of making the model. So I had to make a model, and that is done. See the model that we're using in this one. Post-operative pain scores between the 3 pain management protocols. So I name it. So I do AOV.df, and then I do less than and a dash, and then I type AOV, and then I do DF $sign, and I choose the post-operative pain score, and then I do a tilde, which is shift and the number next to 1, and then DF $sign pain management protocols. And then I could run this and it would create my model. So one of the assumptions is, do I have variance within the model? And I could find this out, or equally between all of them. And I could find this out based off of plotting the ANOVA model. So there's a couple things I can do. The ones that look for this is where's that? Is to see, and like in this one, do I have variance across them? I have some issues with this one personally, because they are very uniform, but whenever you have stuff on a pain scale, this usually is kind of what happens. This also, let's just look at Cook's, the fourth one looks at outliers based on Cook's distance here. So anything outside of here would be outliers. And this would let us look at normality. That -10 kind of gives cause for concern, and also kind of affects the homogeneity of variance. But for the more or less okay part, it is okay. And if you want to get down to it, you can also say that you would possibly do central limit theorem, because you can always get more scores. So we're going to call it okay. And then from here, we're going to look at one-way ANOVA. But we've already built the ANOVA. We just had to get the results. So that you find that out by doing the summary of AOV.df. So we can see here that we have DF of the pay management protocol. That's our level. Degrees of freedom 2. Summer squares of 28.5 and a p-value or f-value, which we need to report the f-value right here of 1.847. And our p-value is 0.227. That means we are not significant. And that you just would write that down here. So we'll get with a DF of 2, value of 0.47, and a p-value of 0.227. We find that there is no difference between groups. So another thing we have to do is effect size. So effect size is, you could do it based off of doing math, but one of the wonderful, great things about this program is that you can use different people's packages, and that we actually find there we go. I'm trying to remember where so there's there's packages to figure out the effect size, which is something that we had to do. So in here, you go down to the console on the bottom, not on the top, but on the bottom. And you can do install packages, open quotes, effect size, all one word, hit enter. And it will install a package called effect size. So I want to go down here while it's doing that, and I can set up effect size. And then I'm going to go back up here and do effect size. I just like naming things. It's good practice to get into. And what I want to do is I'm trying to make sure I get this. There is a specific one that I use. Oh, it's ETA. That's all you do. What I do is I do effect size and then 2 colons, and then I could do ETA squared, and then I do the name of my model, and then I do partial equals true, and then I run that, and it tells me AOV.df, thank you, that my effect size, which is that eta squared, is 0.35. So and it also gives me my confidence interval if you need to report that, which is nice. So the interpretation, which we have to talk about. There is no difference between groups in the ANOVA. If there were, here is how I would find out. So we're going to do separation of means. So this is a Tukey test. Type Tukey HSD and the name of my ANOVA. If you're doing more than a simple one-way ANOVA, you would have to do a comma and then do the name of your level. I'm not doing that. I'm just doing a simple 2 keys, and I can hit that, run it, and it would give me my p-values between B and A, C and A, and C and B, and would let me know what are different. And then what I would want to do from here is I want to go into box plot, and then I could do DF post-operative pain score, and then I want to select that, and then I want to hit the tilde, and I do DF $ pain management protocol, and then I would run that. And if I had the two keys, I could see the difference between the pain scores. So something happened in C, maybe a miskey, maybe not, that caused all this. Made it not difference. And then from here, I would just come down here and do talk about what you did and the results in the bottom. And then from here, once everything's done, I save and I knit. And once you do that knit, it will create a PDF which pops up that you can just save. I don't know if you can see this or not, but there's a little download button and it gives me all the stuff right here. It shows me the headers, shows me everything. And then this is all you would have to turn in for me. Your professor may differ, but this is all I'd want to see from me for the assignment. Hope this helps.